this could be improved. Anyway, thank you for the need.
Thank you for the introduction. This is a part of my presentation as well. Okay, so these are the subtopics that you will learn during this bootcamp. We want to show you what human-machine interface, user experience, graphical user interface is before you go into AR and VR, because they will help you understand how AR and VR works in more detail. It's more easy to understand that way, and how a machine and a human interact with each other, as Mr. George said. So first we have human-machine interface. So what is it? It is a user interface or a dashboard that connects a person to a machine, a system, or device. An easy example is our phone, tablet, or TV. A more complex example will be from industrial processes, such as this one. This example right here is a plant floor operator, and an operator can view the mechanical inside of the performance and the progress of the floor. You can see the pressure, the temperature, and other values, whatever you want to review. Depending on the application, you can change this interface. And of course, you can see if something is going wrong, if some results are not as they should be, and so on. But you can also control, switch, and so on. Another example is our at homes. Now we have smart, well, whoever has smart homes, mine is not smart. My air conditioning is with a controller, but if you have a bit more advanced, you can control your temperature, and you can even control lighting and other things. And of course, another very common example is in our car, we have a monitor. Everyone has now a display on their car. You can change the temperature from that. You can change the radio, use your maps. They're all smart now. That is considered a human-machine interface. So what is the purpose? Of course, as it can be obvious, it's obvious that we have higher performance as we can visually display the data. It is more understandable in a faster manner to understand the data when they are visual, rather than you have to check and read every single line. It does the production in a faster and real-time process. You can see the key performance, you can monitor it anytime, you can control it. And of course, you have everything in one monitor. We mentioned here GUIs, which they're often confused with human-machine interface. GUI is graphical user interface, and that focuses mainly on the visual aspect of the human-machine interface. It's a part of human-machine interface. So human-machine interface covers both graphical user interface, user experience, and it's a part of augmented and virtual reality. So what is the future of human-machine interface? You can incorporate other technologies like AI, advanced data analytics, and by incorporating with AR and VR, you can have so many possibilities, even more efficient processes, even for personal use or for industrial use. Here is a video. I'm not going to go into that. It explains a bit more technical terms of what a human-machine interface is, but it's for more industrial setting. Okay, so user experience. 1 second.
Just a reminder that all slides include links to videos and other links. So based on the constraints that we have in today's presentation, you can then go to our website, download the presentation, and view the long videos at your own pace, at your own time. Okay? So I would suggest to go back again and see all those links, because if we watch a 10-minute video here or 15-minute video here, then we would waste the time, but I would suggest to go back and regular watch links.
Okay, so user experience includes the entire process of acquiring and integrating of a product. It includes branding, developing, design, usability, function. As you can see here, it's an iterative process. First, a researcher will search for what the people need. They will get feedback from surveys, tools like Typeform, Google Forms, or other type of forms in order to do their product. Then they will specify the user requirements and ask this is for the user experience researcher. Then you have the user experience designer, which will use those requirements in order to create a design, a solution. They can use different types of tools such as Miro, Whimsical, or Adobe to use with stakeholders or other partners to get their idea across. And then they will evaluate against these requirements. And then the first product or the first version of the product will be released. And then constant feedback from users will go through this process again and again. This is another example of the process of the user experience design. It's pretty much what I've covered before, but you meet the user, get the demographics, you empathize. Of course, you need to personalize with the user in order to get a more accurate product or a website, or depending on what you're selling. You want to make it simple, of course. You want multiple tests, and you can have beta testing and so on, and then develop. And then you go back to research all the time. If you want to stay up to date, you won't have to do constant research. An important thing is that 88% of people that used a bad website for shopping, they will not return to it. I don't know, the girls here or maybe guys use online shopping. For myself, it's very important, the experience I have with the application. If I don't have a good experience, I might not be using it again. So what makes a good user experience are these characteristics here. It must be usable, so easy to use. Useful, so it has a purpose, it has activity, it has a task. It is desirable, not only for how easy it is, but also how it looks. So it will be interesting, it will be nice to look at, nice aesthetic, depending on what the product is, of course. Findable, so it's easy to locate features and buttons and so on. And of course, it must be credible from the company selling it. The most important part, I will say, is accessible. And here we can see what I mean by that. So we have different types of disabilities. It's either permanent, temporary, or situational. And of course, it varies with touch, sight, hearing, and speaking. You want to make a product or a website or whatever you're doing to be able to fit all of those scenarios. Not only because it's ethical to include all of these people, but also you will have higher success, higher sales, and so on. So an example is if you use a good color setting in a website, let's say, not only a person that, not only a blind, well, a person that has issue with their eyes will be able to see, but also a normal person will be able to see. So it doesn't have to be just for the disabled. Good design, good color is for everyone, of course. For example, voice control will be beneficial for someone that cannot see, but it could also be used for someone that is driving and wants to listen to a message or something. Of course, I don't suggest using your phone while driving, but it's just an example how you can use these technologies to make your life easier, not for just a person with no disability, but with person with disabilities as well. Situational, as we said, is for something that it's not all the time. It's for a new parent that holds a baby, so they only use one arm, or people that have heavy accent. I don't know who saw the video with the elevator and the Scottish people trying to talk to it. That's an example that it did not work for those kind of people. And we were excluding them, not on purpose, but still excluding. This is the Google's Heart framework, and it's a nice way to measure the user experience, how successful it is for a product, for a website. We have happiness, engagement, adoption, retention, and task success. So for happiness, for example, what is the goal? To find the app helpful, fun, and easy to use. How will the user translate that to you? Of course, they can't come to your company and make complaints. I mean, it's a way, but not a suggested way. They can respond to survey, they can have ratings and feedback. And how would you know as the user experience designer? You will see the score, the satisfaction rating, and the number of the reviews, and so on. So this is a good way to understand a good user experience.
So just a moment here, everybody knows about Apple Vision Pro. That it was 4,000 euros, 4,000 dollars. So it was so expensive, but the users started not using it after a couple of days. Why? Because they were getting tired, because the user experience was not what they expected. Then they get rid of it. They didn't have retention, they didn't adopt it. The engagement was not as expected, and a promising, so-called promising product died, I would say, almost instantly. So the idea was good, but many of those things out there were, I would say, missing. Okay. So it's not VR, it's a good VR thing, it's good AR, etc. If you don't have all those points and mark them and have feedback from multiple users, then you will think that everything's okay. And at the end, the actual user will abandon your product. Okay?
So we have user experience and user interface. What is the difference? They're both part of human-machine interface. User experience, as we said, it has to do with users and their experience. I think it's quite straightforward. But user interface has to do with the visual aspects of an interface. And we can see a better example here. So a graphic designer has to focus on the visual and is more specialized, and a designer, user-focused and multidisciplinary, but they both have to have creative thinking, emotional design, and prototype. And they work together, of course, because some designs might not work for the backend, and some and vice versa. This is another illustration to show the difference. A UI designer is more visual designer. They choose the color, they plan the aesthetic, and they are experts in mockups, graphics, and layouts. While a user experience designer is interaction designer. They chart the map of the pathway, they plan the information architecture, and they do the prototyping. So what is a graphical user interface? I mentioned user interface, but now this is a graphical user interface. Older generations might be might know command lines, which is also a user interface. Now the most popular is graphical user interface. I didn't really use command lines, to be honest. And of course, you use icons, buttons, and menus. And you get your relevant informations and actions. So it's even easier for someone to use a website, a product, an app. Everything is straightforward, and you use different type of techniques to do that. You have direct manipulation, so directly interacting with the elements. You have shortcuts, drag and drop, tooltips, which you get a text of what the button will do once you press it. Right click, menus, etc. For me, from all of this, drag and drop is my favorite. You cannot believe, I mean, I might be a bit dramatic, but drag and drop has increased my efficiency a lot. Everything now has drag and drop. I used to press upload, trying to find the right pathway to my folder and to my file, but now everything is drag and drop. So for me, it's my favorite part. Again, we have some principles for the GUI design. It's similar to the user experience design. Must be visible options, affordance. So you will know what that button does. Feedback, so you get from errors and actions and you change it accordingly. Consistency, so you can see that most things now have similar icons, so everyone can use different platforms. User control, so there's a nice flow to the product. Simplicity, tolerance, and forgiveness. This another very important is when you try to delete something and it asks you, do you want to delete this? Are you sure? This is very important in some cases. And we have different types: desktops, web, mobile, touchscreen, and of course we have VR and AR, which is what we're going to be looking at later on. And of course, the same as user experience, these combine with voice technology, haptic technology. It can be very advanced and are used with AR and VR. So here's the fun part. What is VR? The devices and apps that turn the real world virtual. So you use modeling and 3D modeling and simulation, and you can interact with a machine, in a virtual environment. So virtual reality is completely virtual. You don't see anything of your actual environment. Usually requires a handset. And you can send and receive information, but you need goggles, headsets, gloves, bodysuits. We have here an example. So for this example, they're using a helmet with a stereoscopic screen, and they simulate their environment with the controller. They move their hand and changing the screen view in real time. Here are more examples. There we have mechanical, industrial. It's a simulation to do maybe a service or something like that. Here is entertainment, and here is again simulation.
The top left, we see that he's wearing gloves with haptic feedback. So the gloves there have sensors, and those sensors, you can see them, they need to the screen. All the motion of his hands are transferred to the interface, and then he interacts with the model with his hand. So this is another way of interacting with the virtual world.
Here are some VR wearables. As we mentioned, these are the haptic ones, the headsets. They sometimes have a bodysuit for full range of motion. And here is a more advanced level where you also get a hub and a small computer. This is for headsets and technologies that need high processing power. You have the screen, you have the sensors, the gyroscopes, the lenses, and so on. Here is how the haptics work. So you have some sensor that sends signals to the software, and they analyze it, and then it converts to the visual part. But this specific one actually is a research. You could actually feel the cold or the heat of what you're doing in order to get a more realistic simulation, a more realistic mock-up of maybe a testing or something like that. Here are some more examples: dining, medicine, media. I don't know if any of you have used a VR in your jobs. No? Any of you?
Raise your hand if you have used VR before. Please raise your hand, so almost most of you.
Okay, who hasn't used it for entertainment? If it's entertainment, it doesn't count. Okay, everyone has used it for entertainment. Okay. What have you used it for? Rehabilitation. It's for science. It's very important. It's for science. And you?
For experiments, for the collecting data.
Collecting data. Okay. So yes, we have for medicine. One of them is sports science. For rehabilitation, it's very useful to get data from the movement, and then, or you can also use it as just a way. For example, you can use it for older people, and you can give them VR glasses in order to make them do their exercises maybe in a bit more fun way, because they dread doing their exercises and physical therapy. And if you give them, they will get excited and play with it. You don't recognize that you're exercising. We have education. Of course, visual education is easier to retain than textbook. Entertainment, games, and so on. We actually have Oculus, which we can play games later if you like. Architecture, they use VR to visualize some aspects of architecture or do mock-ups for a space, for an environment. Industry is the most popular. We have culture and art. Many museums now have some sort of virtual reality or augmented reality. And military for training. Here are some more examples. You can see what the person views in the headset, and this is what happens in real life. You have to be careful because you don't want to break anything. You have to be in a more confined space. Here's the military training, simulation, and pilot. I don't know if you believe this, but actually in Cyprus, we don't use this for our pilots. And education. Now we have augmented reality. What is the difference between virtual reality? I will explain in a bit. First, augmented reality is an interactive experience that combines the real world and computer-generated content. So, as we said before, virtual reality is fully in a virtual environment. Augmented reality, you don't need a headset to view it. You can use your phone, a tablet, or a smart device in order to view this. You usually scan a QR code and you can view. It can also be confused with extended reality, but extended reality covers all of the aforementioned. I will explain a bit. Mixed reality is when you interact with, so you have the real world, the 3D design, and then you can interact with it. So when you interact with it, it's called mixed reality. Again, as I said, the difference is that you have fully virtual environment and you need a headset. So this is extended reality. You have the real life. You have AR, which is digital objects in your environment, in the real world environment. So if you open it now, you will see the classroom and then you will see an object. Mixed reality, as I said, you interact with those objects. And then we have VR, which is completely virtual. Of course, when it's mixed with interaction, it could also be considered mixed reality. So extended reality is an umbrella term that covers all of the technology that alters the reality by adding digital elements, either in the physical or the real world environment to an extent. That's why it's called extended reality.
Just remember that we have sensors, and the most important sense is visual. We have auditory sense. We have haptic feedback from our hands. We sense temperature. We sense vibration. So ideally, if we have an external trigger to our body that it uses all those senses, then we might be able to feel like it's real. Okay, so extended reality tries to imitate reality by activating in as good as it goes our senses. Okay. Number one, visual, and then audio, and then other senses.
I have some examples here. The most popular, well, not Snapchat, I will say TikTok maybe. I have used many filters. I used mainly for my hair. I wanted to see what I would look like with gray hair and what I will look like when I grow old. It was not good. We have photography, Google Glass, HoloLens. This is the most popular, I think, one of the first technologies I ever used that had anything to do with augmented reality. It's Pokemon Go. It became popular in 2016. So you will go to the real world and capture Pokemon characters. We have Google Air Core, Air Maintenance, and Google Street View. Google Street View, again, is one that can be easily used by anyone. When you can't really locate yourself on the map, you can use Google Street View and you literally follow the arrows. I have used this in Italy before. It was useful. We have interior decoration apps. We will show an example for this later in the workshop, actually. Architecture, virtual sneakers. So what will the shoe look like on you? And hair coloring. And even more, as we said, we have in the museums, surgery, tourist, and in newspaper. So we showed you the examples of all of these technologies, but what are the key technologies in doing so? One of the first and the most important is your design. You can use any different type of software to do a 3D design. Most popular Blender, Tinkercad, Fusion. If you're an engineer, maybe SolidWorks. And they enable you to control the shape. You can do as advanced as you like, or maybe just a circle, whatever you want, and you can export that and add it to your model. You can scan existing models using your phone. And one of those examples, you can use the camera. And with this, is it technology, I will say, this is a method of using the camera. It's called photogrammetry, and you capture multiple images and it converts it into a 3D model. I think we will show that in the workshop as well.
Yes.
There's an app called Polygram, and you get an object like that one, and you take multiple pictures in small frames, and you can get a design. Of course, with more advanced cameras and with the more images you use, is gonna be more accurate. So if you're gonna, let's say, if you wanted to 3D print something, you would need high precision. And then you have the LiDAR sensors, which this also covers the environment usually, and gets the light detection and ranging to measure the distances and create that 3D map. And then, of course, you can combine those two. And the other part is the interaction. So how do you actually interact with the object? You have accelerometer built in your phone. So when you try to use a 360 video, for example, or from YouTube or anywhere else, and you turn it, that's how it recognizes the motion. A mouse. So if you're doing it from your laptop, you could see that based on optical flow sensor that the mouse has, it recognizes the movement. Then we have gesture control, which you can pinch, swipe, wave. You can either do it by a camera or a lip motion sensor. And the other inputs that Mr. George mentioned is gloves, controllers. All of these use motion and object tracking. And this is just for you how to move the virtual world. If you want to feel the virtual world, you will use headphones for the sound. You will use special gloves to feel the touch, as the ones I showed before. You could wear a whole vest that could create maybe some motion, some punch, and you could feel a more realistic example. This is again how you combine those things. So you can camera calibration. If you're doing something simple, you don't need a camera calibration. If you use your camera, it's calibrated already. Then you track the object or yourself, and then you register it with the real environment and combine it. So these are some examples of tools you can use to create augmented reality. iOS ArtKit, Vuforia, Microsoft Mixed Reality Toolkit. I think one of the most known is Unity. But for commercial use, we suggest this one, Flipart. It does not require any coding skills. You can just upload 3D shapes into a flat surface and generate, you can change the shape, color, whatever you want. You can have multiple.
This is not educational, okay, for educational purposes, not like Unity in which you can create real words, okay, and for game purpose.
Or maybe some marketing or something like that, not something advanced. And once you are finished with your design, I think we're gonna do this as well in the workshop. You can scan the QR code and review it on your phone and see what you have designed. But there is actually they have a preview setting as well. But if you want to test it directly on your phone, you can scan the QR code. So what are some jobs that you can get using user experience, augmented reality and virtual reality? It's XR developer, software development, AR and VR maintenance, XR designer, software engineer, product manager, XR gameplay engineer. So if you want to, depending on the industry you want to go in, there's of course a need for all of these people. Even if it's in medicine, let's say, again, you will need an XR developer or a gameplay developer to do this. You wouldn't want a doctor to do the design for you. So these are some potential jobs. And here we have your further reading, if you like, to check some even more material. I tried to do this as it is an introductory course in AR and VR. And we wanted to do it as simple and as brief as possible because we wanted for you to check out the actual workshop and get your hands on the Oculus and the VR material, sorry, the AR material we prepared. Once we're done with the workshop, I would like you to give us some feedback as well. But we will see that later.
Product, title, I would say